Hi, and welcome to Train Signal. We're continuing our Advanced Services course. This is the lesson on configuring cluster-aware updating of failover clusters. So you've got your failover cluster up and running, things are running smoothly, your boss comes to the office and says, boy, I was on the train on the way into town and I was sitting with another manager who told me about a disaster they had with a failover cluster that they had. Some of the servers weren't patched the same way as some of the other servers. And boy, it was a great big mess and there was a lot of downtime and millions of dollars in revenue lost. I am so glad that you're keeping our failover cluster up to date and everything's running smoothly. Pats you on the back, walks away. And you think to yourself, oh, I should make sure that we've got those things patched properly. That might be important. How do we make sure that we get all of these servers, and we could have as many as 32 of them in our failover cluster, how do we keep all those servers up to date on their patches? Because after all, those patches do need to get applied. It is Windows after all. And that being said, patches do need to be applied. In many cases, that'll trigger reboots of servers. There might be a whole series of actions that need to take place on servers. You've got 32 servers, you've got services running on each of them that need to be moved off. We could go through a fairly elaborate process of trying to figure out exactly when to upgrade which server, or we have an alternative. Instead of planning the sequencing of which roles are going to get moved off of which servers onto others temporarily so that we can then update that particular node of the cluster, throwing it through a reboot after having, of course, moved it into maintenance mode, and of course back out of maintenance mode at the other end of the installation process, and then failing back the applications we failed off of that node back to that node so that we can then repeat that process with the next node and then repeat that with the other 30 servers after that. That's an awful lot of work. Is there an easier way? Well, of course there is. Microsoft has rolled out something called cluster-aware updating, in which case I can take one of a couple of different approaches to be able to cause my set of servers to download their appropriate set of patches and roll through an iterative process of upgrading each server with the appropriate set of patches without all the manual intervention that had been historically associated with upgrading patches on our failover clusters. The two strategies involve either a remote updating approach or a self-updating approach, and we're going to demonstrate both of them as we head into demonstration here in a moment. The general idea is I can either have my servers go through a process of updating themselves, where somewhere on the cluster is a clustered role, the self-updating service, which will trigger the updating process and fail itself over to other servers to be able to allow the server that it had been on to go through that updating process. That failover service floats around the cluster as it updates all the various servers. Everything comes up to date. The other strategy, remote updating mode, is one in which we're going to dedicate some specific computer in our network. It might be a client OS, it might be a member server, it might be some other server in my organization, and I want to be able to have that computer be the conductor, be the orchestrator of the updating process on the servers. The servers themselves will not host the updating process. The updating process, the orchestration, is all done from a separate computer. So let's jump to the demonstration environment and I'll show you setting up both of these kinds of environments. So here we are over on server 1. Server 1 is the domain controller for my environment. Servers 2 and 3 are my failover cluster. So here I'm on a computer that's not part of the failover cluster itself, but it's part of the network that contains it. But we'll see that I am able to remotely administer my failover cluster from here. Now at the moment, my computer doesn't have a failover cluster tool on it because I haven't installed the failover cluster software on this computer at all. That's easy enough to do, and in fact I can install just the management components if I choose to. I might do the same thing if I was making configuration settings on, for example, a Windows 7 or Windows 8 client computer. I can install my configuration components there as well. Choosing which server to install upon, that's of course going to be server 1, this one. Click next. I don't want to install a role, I want to install a feature. And the feature is not failover clustering proper, but the remote server administration tool components related to the feature whose name is failover clustering. And inside of that collection, I can see failover cluster management tools, which when selected does enable the cluster aware updating GUI, which is exactly what I'm looking for. I could alternatively do the same thing through PowerShell if I felt like it. can install the failover cluster module. In this case, I'm going to leave that alone and just go ahead and click Next. It's offering me a preview of what it's planning on installing. That looks good to me. I'm going to click Install. That's going to take a few minutes to install, so I'll push my magical TrainSignal failover clustering tools speed up button, and that'll speed up this installation nice and quick. And there we go. Wasn't that quick? Try doing that in a sit-down classroom. Okay, so we've installed our cluster aware updating tool. We can see that here in the tools menu. There it is, cluster aware updating. We could also get access to the same tool from the main failover cluster manager GUI. When I jump over to the actual failover cluster servers later, I'll illustrate that from that side. But for the moment, let me go just jump right into the cluster aware updating GUI, in which we can identify which cluster we want to be able to configure. I've only got one, so we'll choose to connect to that one. And we can then begin seeing what updates are available for this cluster. I'm going to click my Preview Updates for this cluster button over here up to the right, and that will allow me to use the Windows Update plugin, the software that connects to the Windows Update service, and use it to see which patches are available for this computer. Now that's going to take a couple of minutes to be able to do its analysis, much in the same way that it does when you go update your Windows 7, Windows 8 client. So I'm going to go ahead and let that update run. There we go. And we've detected a couple of updates for servers 2 and 3. Alright, looks good. So the next logical thing to do would be to go apply those. I'm going to close my updates window. I'm going to prepare to apply updates to this cluster. And when I do, we'll see we've got an intro window that wants to tell me about what we're about to accomplish. I'm going to click Next, and it wants to know what file contains the run options that I want to use as my starting point. It is possible to build your own custom file that contains a particular set of default values for these settings that we're going to talk about down here in just a moment. In this case, I'm just going to go ahead and use the default parameters as my starting point, and I'll tweak them live here. Stop after and warn after. Give me a timing deadline for this execution of the failover cluster updating functionality. The technical term that Microsoft uses to refer to an updating procedure of that sort is what it refers to as an updating run. So I configure an updating run, and I request an updating run, and the updating run happens. So during this updating run, I can specify after how many minutes I want this process to come to a halt. I might know that it ordinarily takes 2 hours to apply those updates, so maybe I'll give it 4, and if it's not done within 4 hours, we'll halt it because something has gone badly wrong. In this case, I know that I've only got a couple of patches to apply. It's probably not going to take more than 5 minutes, maybe 10. So let me give it a full hour just to be on the safe side. We were measuring this in minutes, something to be alert to. Warning will indicate in the updating GUI if it seems like it has not finished by a certain interesting percentage of that. Maybe after 50 minutes, if I haven't seen a completion of that process, I'll throw a warning that I can see in my GUI to let me know that, hey, it's not done yet. That's kind of weird. I might want to go check to see what's going wrong. Below that, retries per node. For each node of my cluster, how many failed installations of patches am I willing to retry and how many times? I might retry patch up to as many as 3 times by default. I might change that to some higher number if I suspect that might be necessary. I might knock it down to a lower number if need be. Max failed nodes is the maximum number of nodes that for one reason or another don't seem to be successfully completing their updating run. If I see more than the maximum failed nodes, I will abort the cluster updating run altogether and try it some other time. Next option is a fairly self-explanatory one. Do I want to require all the nodes in my failover cluster to be online before I start the updating run? And in general, if we have the opportunity, the answer is probably yes. Of course, we'd much rather that. I want to make sure that I do all of my service updates consistently so they all operate the same way. That's perfectly logical. Below that, node order. I can specify a list of computer names here to identify in which order I want the clustering process to target my various servers. So I could say nyc-svr3 first and nyc-svr2 second, perhaps. as a way to indicate that I want to do them in that order. If I don't specify an order, the system will apply patches in order, starting with the server that has the fewest clustered roles running in an active mode on that server at that time. And then it'll start working its way up to the servers that have a greater quantity of roles running on them. Reboot timeout is a way of being able to put a maximum time on the amount of expected reboot time for a particular server. I'm going to apply patches to a server. That server takes a reboot. During the reboot process, it might take some time to be able to configure the patches that have been installed. So we need to give some greater than normal amount of leeway for the reboot process here. But maybe I know that it'll take maybe as much as 5 minutes to reboot a server. If I configure it that way, I'm able to indicate exactly how long I'm willing to wait for that server to finish rebooting. If it has not come back online, if the cluster has not detected that that server is back online in whatever it is, 5 minutes, 10 minutes, then it will mark that as a failed node, and that counts up here towards the max failed nodes maximum. Below reboot timeout minutes is the option for a pre-update script and a post-update script. If I know a particular task that I really need to do on my failover nodes before and after the updating processes occur, I can actually build a PowerShell script that I want to run as a bit of pre-work and as a bit of post-work to bookend the installation process on those nodes. That's kind of a neat trick. In so doing, I can specify a PowerShell configuration. If those scripts are to be run within the context of a particular PowerShell configuration environment, I can name the configuration that it's meant to use. That's an advanced PowerShell topic. We'll save that for a PowerShell course. But if I'm doing sophisticated PowerShell things, I may want to have that degree of flexibility. Below that, we identify the plugin that we're using to be able to get our patches. In this case, the Windows Update Server plugin is a fine choice. We've got the other option of the Hotfix plugin if we're installing hotfixes. In this case, we're installing mainline Windows updates. And I can supply arguments to be able to calibrate that plugin to be able to turn on advanced features of its operation. Having done that, we've reached the other end of our updating configuration setting identification phase. I click Next. It's going to give me the option to grab not only important updates but also recommended updates. In this case, I'm going to leave it as is. Click Next. It reviews my set of options, and I can now prepare to update my cluster. It has kicked off the cluster updating. I'm going to cancel this wizard, and I can see that this cluster has detected an updating run and is now preparing to apply patches to my two servers. We're hunting for Windows Update patches out there in the internet. After it finds them, it's going to download those appropriate patches, and it's then going to prepare to install those patches onto the relevant servers. So far, these servers are still running in a perfectly ordinary sort of a mode, but once it has downloaded those appropriate patches, it's going to take a given node and throw it into, again, what's called maintenance mode to get it ready for the updating process to occur. It'll apply the patch, trigger the reboot. When it comes back out of the reboot, it'll remove it from maintenance mode, put it back into production, and move on to the next node. I want you to visualize the idea of this happening not with just one patch, but dozens of them. And I want you to visualize those dozens of patches being applied not to 2 failover cluster servers, but a cluster of 8 servers, or a cluster of 16 servers, or a cluster of 24 servers, or even the maximum of 32. Consider the amount of work that this removes from your plate, while at the same time dramatically improving the efficiency, the accuracy of that installation process. This updating process is going to take another couple of minutes, so I'm going to push my magic train signal accelerator button and speed up the apparent speed of this process. Ready? Here we go. So we can see that the updating process has run its course, and in this particular case we had mixed results. Server 3 took up its changes just fine, but Server 2 hit the max failed nodes limit. We found that there were failures on New York City Server 2. Came around a couple times, and eventually it said, hey, that's not good. We got 3 failed attempts. we're going to bail out. We're going to mark that as a failed node. I set a max failed nodes of 0, so that was plenty enough to terminate our updating run. That's design behavior. Now, what happened on server 2? Well, we could go do some exploring. We could figure out what happened to our patching environment that caused that to fail. For the purpose of our clusterware updating demonstration, this is exactly what we wanted to see, that we can trigger updating across multiple servers. I want you to envision not one patch and 2 servers here, but dozens of patches and dozens of servers, all updating each other, getting updated on an automated basis with minimal necessary effort. In the case where a server, in fact, can't take up an update, of course, it'll let us know. So that is good news. We now know exactly where to look to go figure out what the problem is that's preventing those updates from being applied properly. Let me jump over to server 2, and let's take a look at this same process from its perspective, and let's look at building automatically scheduled cluster updating from server 2. So over here on server 2, I'm going to go to my cluster updating tool. Here's the main failover cluster manager. I could launch the failover cluster updating tool right from the administrative tools menu in server manager, but alternatively, I can also right-click my cluster, come on down to more actions, and over here is the option to begin doing cluster aware updating. Same feature, just an alternative way of accessing it. A third, of course, would be to click the link right here that says cluster aware updating. So we could do that too. Okay, so we've launched the cluster aware updating GUI. You can see that I'm connected to my GlobalMantix failover cluster. It's got my 2 nodes in it. I can repeat the same go update right now approach that I did before, but I've also got another option here that deserves our attention. The ability to configure cluster self-updating options. We go choose that link. Okay, so the self-updating options wizard is online, gives us some basic information. And as I click next, we can see in this first major screen for the wizard that the way the self-updating tool works is by installing a new clustered role. In addition to the virtual machine roles, the DHCP server roles, the other roles that I've configured to fail over and fail back across my failover cluster servers, I can add a new role dedicated to the job of doing cluster aware updating. So in other words, one of my cluster members is going to be a DHCP server if I'm doing DHCP clustering. Another one's going to be my, whatever it is, SQL Server box perhaps. But another one is going to be my CAU. It's going to be my cluster aware updating server. And periodically, I'll get to the point where I need to update the server that holds that role, so that role will fail over to a different server so that I can do an update on the server that was holding the role. So I can indicate here that I intend to add that role, which of course is the main goal of this particular wizard. By default, this process is going to create a new computer account in Active Directory, much in the same way that we created one for the DHCP cluster. If you attended the lesson that focused on building a DHCP failover cluster. And in the same way, you saw that when we first installed the failover cluster, if you attended the lesson for installing failover clusters, that creates an object in Active Directory, a computer object that represents the cluster. Same idea here. We're going to create a computer object in the domain that describes this process, that describes this virtual server that's being hosted at my failover cluster. If you configured your permissions correctly in Active Directory, giving the failover cluster object write permissions on the OU that contains the failover cluster computer, then there'll be no problem with the cluster server creating the computer for you. If not, you can identify that you have a pre-staged computer object. Somebody went ahead and pre-created the computer account object in Active Directory, and I just now need to associate this new CAU clustered role with that computer. In this case, I'm going to let it create it. That's fine. So I'm going to click Next. Next step is, how often are we going to perform our updating? And that's driven entirely by your corporate IT policies. It might be a weekly schedule. Once a week on Friday evening at 11 o'clock at night, we're going to start up our updating process. Perhaps. That way it's got couple of hours to do its thing, and then we're into the weekend, and because most of our work on that set of servers happens on Monday anyway. Next set of options are again the updating run configuration settings that we saw before. And once again, I can use the built-in ones. I can customize them manually, or I could load up a different updating run parameters file if I had one. So having made any appropriate changes, if any, I'm going to click Next. Final options again related to recommended updates. I click Next, and note that we are running a different piece of PowerShell code this time, add-cau cluster role. Name of the cluster, plugin name, max retries, all those sorts of rules. But what we're doing is we're telling the server to add a new role to the failover cluster, just like I'm adding a new Winds server, where that role lives on the server and it, on a scheduled basis, will perform updating runs. So this next part of the video is going to take a minute or two here, but here's what I'm going to do. I'm going to push the magic train signal button, and this is now going to run much faster than it would in real life. And there we go. We've added a self-updating agent to our failover cluster so that no matter what clients are installed, these servers will periodically, and in this case on a scheduled basis once a week on Friday evenings, kick off a process of doing a scheduled updating run. Of course, it'll be incumbent upon whoever manages this to check back and periodically see if it's succeeded or not, and go look at the details about the updating procedure, see exactly what has happened with it. But that being said, we were able to dramatically improve the efficiency of patching, dramatically improve the reliability of it, the consistency with which we can patch a large number of servers in a way that is equivalent across that entire family of servers. I hope that functionality is going to be helpful to you as you manage your failover clusters in your Windows Server 2012 environment, and I look forward to teaching you more about Server 2012 in a different lesson.